This has been grade A rated on page 294. I don't think it is actually, but never mind, it's very, very creative. Again, this is bearings with simultaneous equations. Again, not a usual context. So let's just look at it very carefully, see what we can do. Look at the picture. Right, I've got a bearing. Bearing of B from A is clearly x plus y. Going across that way, I should write it in. And yeah, that's what I've got so far. X is 24 larger than angle Y. Yep. The bearing of A from B is 256. Okay, I'll make an addition to the picture in a minute. Find the values of x and y by forming two linear simultaneous equations in x and y, and then solve them by substitution. Okay, I can do that. And write down the bearing of B from A. Now listen, let me add to this picture straight away. I've got a 256 to deal with, and now this is the 256 they're talking about. The bearing of A from B. The bearing of A from B means start at B and track clockwise like that. Now that number is, and I better go blue, it stands out, is 256 degrees. Alright? But look here, if I extend this black line a little bit by doing this, well, we'll try and aim better than that. There you go, that's not too bad. By extending this black line, can you see that this angle here is in fact the same as x plus y, because they are corresponding angles. Now we know the angle from here to here is 180 degrees. Therefore I can work out the value of x plus y by subtracting 180 degrees from 256. And I want to do it right here, right now. So here we go. 256 degrees, the full bearing, and I want to take away 180 degrees, which is this part here, and that will give me something or other, 20, that'll give me 76 degrees. Is that alright? Just check on myself again. Plus 20 takes me, yeah, 76 degrees. Therefore, I've got myself an equation. I have got, let's put it here because this is where I've worked it out, I've got x plus y comes to 76 degrees. Now, for this one here, angle x is 24 degrees larger than angle y. In other words, y, if I add on 24 degrees, I will make angle x. So very, very, very easy equations. A little tricky to get hold of, but that's them. That one and that one. Now I should write them down here and merge the two and do part B. So I've got my simultaneous equations. I will now work out x and y. So that's 24 equals x. Now I've got x plus y all comes to 76 because the bearing calculation over there. By substitution, I think I can say here that x equals 76 minus y, just by taking the y over and subtracting. And why don't I put this term here straight in the x right there? Eh? Why don't we do that? So here we go. I've got y plus 24 equals 76 minus y, because that's what x is worth. Look, x and x and x. Bring the y's together. So 2y plus 24 is 76. Let's subtract the 24 from the other side. So 2y is going to be 76 take 24, 52 degrees. So y is going to be 26 degrees. Is that alright? Lovely, isn't it? Now let's work out what x is worth. I've got x plus y comes to 76. That's from here. I can plant my 26 in the y. So x plus 26 is 76. Subtracting from the other side. Therefore x is going to be 50 degrees. Alright, so I've got my y and I've got my x. Now, what have I got here? It says write down the bearing of B from A. Now listen to the English of this carefully. Write down the bearing of B from A. In other words, I've got to go from the north line clockwise, and that's it, and start travelling towards B. Well, the bearing of B from A is x plus y, isn't it? So therefore, this equals x plus y, and I've worked it out before. There it is, 76 degrees, because that corresponding angle there matches that one right there. And not a problem, which equals, let's just show that I've got my two angles separately anyway, and show the examiner how I blended them together. So I've got 26 plus, what is it, 26 plus 50, and either way I'm going to get 76 degrees as my answer. That is my bearing of B from A. That's beautiful. Here's the next question. This has not been given a grade, but I can assure you from what's coming up this is a grade A question. There is also a misprint in the book. It says in the diagram the ratio of x to y, there it is 5 to 4. O is the centre of the circle, oops, circle theorems, and AB is a tangent to the circle, definitely circle theorems. Set up a couple of simultaneous equations with x and y, and then use your answers to x and y to find angle Z. Now in the book it says angle Y. Now there is no angle Y. In fact, they've already asked us to work out angle, work out Y anyway. But what they mean is this angle right here, the Z angle. Now, look, this is not graded. It's gone beyond the grade A questions, probably for a reason. But it's not too bad if you can see your way through it. If this is a tangent, it would have been awfully helpful to us if they did this, wouldn't it? Look, proper tangent. Now, if you can see that's a tangent, and let me just guide you through this a little bit here, because it's tricky. If this is a tangent to the circle, red please, if this is a tangent to the circle, and here we have a triangle touching the circle at the 3 vertices shown, can you see that this angle equals angle x because of the alternate segment theorem? Okay, here is a chord A going straight through to the other side of the circle. It's not a diameter because O rather is the centre. So this is a chord. So look, this angle here touching this side of the triangle forms an angle, and it's called 2y minus 60. But therefore, according to the alternate segment theorem, which is this is the alternate segment, the second segment on this side of the circle, not on this side of the circle. Therefore, they're the same. So I've created a simultaneous equation. X equals 2y minus 60. I may need to tidy up and rearrange it later, but essentially, using alternate segment theorem, that's grade A, stroke A star, I've highlighted that x is 2y minus 60. Now that's one equation. Now the next thing I've got to do is sort out this little part here. Now look, this is my next equation. If x to y is 5 to 4, then x divided by y is just like saying 4 over 5. Alright? That's beautiful, isn't it? So what have I got? I can have an equation in x by saying x equals 4y over 5, or I can do some other kind of gymnastics to it. So look, why don't I substitute this x part of the equation straight onto that, and then just play around with it, tidy it up, so I end up with an equation in y. There's probably an easy way of doing it, but that's the first thing my brain saw. So let me just do it. I've got 2y minus 60 divided by y equals 4/5. Okay? Not a grade A equation at all, it's grade B in fact. Cross multiply, so I've got 5 lots of 2y minus 60 equals 4 lots of y. Again, 5 goes up, y goes up. Alright? Multiply out. 10y minus, is that 300? That's big, isn't it? So 10y minus 300 equals 4y. Bring the 4y's over to me. So 10y minus 4y equals, the minus 300 next door becomes plus 300 on this side. So 6y equals 300, from which y becomes 300 divided by 6. 6 is into 30, go 5 times, hence 50 degrees. Y is 50 degrees. Therefore, let's work out what x is. Working up here now, I've got x divided by 50 equals 4 over 5. Therefore, x equals 4/5 of 50. Take the 50 over and multiply. Cancelling down, obviously, look, 1 and 10. Of course, you can use a calculator, can't you? So x is going to be 4 times 10, 40 degrees. And that is a very, very beautiful creative question. Now, part B. Use your answers to work out the value of z. Oh, alright then. Well, that's not too difficult. I know, for example, that angle x here is, what is it, 40 degrees. Let's just put a 40 in there, because x and 2y minus 60 are alternate segment related. And here, what if I put a 40 there for the x, and the y will be 50. I'm going to do a quick sum, then subtract from 180 and get z. It is, after all, a triangle, isn't it? So let's try and work in this little corner here. Let's just add these two up. I've got 40 for the x there, and I've got plus 40 for here, plus 50 over 2, that comes to 80, plus 25, so that's going to give us 105 degrees altogether for this angle and this angle here. Let's just check it. 40 plus 40 plus 50 over 2, yeah, that's correct, isn't it? Therefore, angle Z is going to be 180, take away 105, and that's going to give us 75 degrees, and I'm very happy to leave it like that. I think that's enough for one video. It's quite long, I'm sure. I will stop and look at some of the very wordy sums, or rather problems that are coming up, but they do yield rather interesting simultaneous equations. So I'll stop there, and that'll be the next and final video in this section.